Hello, my dear students in grade 9. This is a new mathematics lecture this week, and we will continue in our lesson that we started 2 weeks ago, which is rational and irrational numbers or calculations. What are the objectives of this week? We will continue what we started last week, how we simplify or reduce fractions. We talked about two cases. Last week, I started case number 1, and this week I will discuss case number 2. Then we will write a number in scientific notation, and finally, how we find the LCM and the GCD of two numbers. Simplify a fraction with powers of 10. We said that we have two cases. There are two cases. Last week, I discussed case number 1. Number 1, when you have a fraction to simplify where all factors in numerator and denominator are written as a product. What do I mean by a product? All the factors in the numerator are multiplied together and all the factors in the denominator are multiplied together. In this case, first, if I have a power of power, I change it to 1 power. Then we write all powers of 10 in the numerator or in the denominator as 1 power of 10. After that, we start simplifying numbers of a numerator with numbers in denominator, then powers of 10 up and down together. As an example, we have 2.4 times 10 to the power negative 2 times 15 times 10 squared, all of it to the power 4, over 0.35 times 10 to the power 5 times 10 to the power 14. Here, all the factors are multiplied, and in the denominator, all the factors are multiplied, so I will apply case number 1. If you look at the numbers, I have 2.4, which is a decimal number. As I said last week, whenever you have a decimal number, you change it to a whole number. To change 2.4 from a decimal number to a whole number, I write 24 without a point, and then I multiply it by a negative power of 10. To know the exponent of the negative power of 10, I count how many digits I have in the decimal part. Since I have 1 digit, so I write 24 times 10 to the power negative 1. Then I write times 10 to the power negative 2 times 15. Here I have power of power. I change it to 1 power. So I write 10 to the power 2 times 4, which is 10 to the power 8. 0.35 is a decimal number. I will change it to a whole number. So I write 35 without a point. Since I have 2 digits in the decimal part, I write times 10 to the power negative 2. 10 to the power 5, I write it as it is. And 10 to the power 14, I write it as it is. Now I write the number multiplied in the numerator near each other's. 24 times 10 to the power 15. The powers of 10 in the numerator, I make them as 1 power of 10. How? I apply the rule of power, which is multiplication, same base 10. I keep the base 10, and I add all the 3 exponents. So minus 1 plus negative 2 plus 8 gives me 10 to the power 5. Down I write 35 times. Negative 2 plus 5 plus 14 gives me 10 to the power 17. Now I will start simplifying. First, I start with the numbers. I ask, is there a common factor between 24 and 35? No. Is there any common factor between 15 and 35? Yes. Both can be divided by 5. So 15 divided by 5 is 3, and 35 divided by 5 is 7. No more common factor between the numbers, so I multiply 24 times 3 is 72, and I write down 7. Now I come to the powers of 10. Up I have 10 to the power 5, and in the denominator I have 10 to the power 17. So I ask, where is the power of 10 more? In the numerator or in the denominator? Of course, 17 is greater. So what I do is I write times 10 down in the denominator where it's more. Then I say 17 minus 5 is 12. So this is my answer in the simplified form. Suppose you are asked to write your answer in scientific notation. Of course, you know the form of a scientific notation. It should be written as a number between 1 and 10 multiplied by a power of 10. So I will divide 72 by 7 using my calculator. 72 by 7 gives me 10.285. I should multiply it by a power of 10. I have a power of 10 in the denominator, so I take it up in the numerator, it becomes 10 to the power negative 12. Since, as you know, when we take the power from the denominator to the numerator, or vice versa, the positive power of 10 becomes a negative power of 10. Now I say, is 10.285 a number between 1 and 10? No, it's more than 10. So I should make it a number between 1 and 10. So I will put the point here. So my number becomes 1.0285 times 10 to the power 1, since I moved the 0.1 digit, times 10 to the power negative 12. Now these two powers of 10, I make them as 1, so I write 10. 1 plus minus 12 gives me minus 11. Please apply this exercise on a draft. The second case of simplifying, if you look at your fraction and you find that between the factors in numerator or denominator, there are plus or minus. Here you cannot simplify by canceling as we did before. We have steps to follow. First, if you have decimal numbers, as usual, you change them into whole numbers. After that, where you have a plus or minus in the numerator or in the denominator or in both, you will factorize. You remember factorizing from last year? We should find a common factor in the numerator and we divide both terms by the common factor. After that, we calculate the parentheses. Now, after this, all the factors in the numerator and denominator become a product, so we can start simplify by canceling. 0.4 times 10 to the power negative 2 minus 0.1 times 10 to the power negative 2 over 0.009. I have a minus in the numerator, so I should follow these steps. First, since I have decimal numbers, I change them into whole. So 4 times 10 to the power negative 1, 1 times 10 to the power negative 1, and 9 times 10 to the power negative 3. This is what I do first. All my numbers now are whole numbers. These two powers of 10, I write them as 1. So I write 10 to the power negative 3, 1 times 10 to the power negative 3 over 9 times 10 to the power negative 3. So I become to this step. Now, here in the numerator, I will factorize. What is common between the factors in the numerator? 10 to the power negative 3 is common, so I take it as a common factor. Then I divide the two terms by 10 to the power negative 3. After dividing, I get 10 to the power negative 3 into 4 minus 1 over 9 times 10 to the power negative 3. Now I calculate what I have between parentheses. What's 4 minus 1? It is a 3. So the 3 is multiplied by 10 to the power negative 3. Now I start simplifying by canceling. 3 and 9 can be divided by 3. So 3 by 3 is 1 and 9 by 3 is 3. In the numerator and in the denominator, I have 10 to the power negative 3, so they cancel each other. So my answer becomes 1 over 3. Please also apply this exercise on a draft. Here you have 3 more exercises on the 2 cases. They are solved for you. Please also, to understand more, apply these exercises on a draft to get the idea in an easier way. Now, what do we mean by scientific notation? Scientific notation, you will have a number. This number is a very big number or a very small number. To write it in an easier way, we use the scientific notation. To write a number in scientific notation, you should have this form, a times 10 to the power n. A is a number between 1 and 10. It can be 1, 1.1, 1.2, 2, 3.5, whatever, 9.9999, but it cannot be 10. It should be less than 10. As you can see here, so A is a number between 1 and 10, and here we have equal, which means it can be 1. And the exponent of the power of 10, which is n, it can be an integer. What do we mean by an integer? N can be a positive or a negative exponent. I will tell you when it will be positive or when it will be negative. This number, I want to write it in scientific notation. First, the question I always ask is this given number between 1 and 10? No, of course, it's a very big number. I should make it a number between 1 and 10. This is a whole number, and as you know, any whole number is 0.0, so the point is here. Where can I put the point in this number so I get a number between 1 and 10? I should put the point here to get 7, since 7 becomes a number between 1 and 10. So how many digits did I move the point from here until it becomes near 7? I moved it 1, 2, 3, 4, 5 digits. So I write 10 to the power 5. Why is the exponent positive? Since the number I'm changing to scientific notation is greater than 10. So any number greater than 10, you use a positive power of 10. 8, is it a number between 1 and 10? Yes. So I should keep it as it is. To keep it as it is, when you have a number and it is between 1 and 10, you will not change it. You always multiply by 10 to the power 0. 122, is it a number between 1 and 10? No. So I should make it, the point is here, I should move it between the 1 and 2 to become here. How many digits did I move it? 2 digits, 1, 2. So it's a positive power of 10 since the number is greater than 10. Also, this is the same. Let me move to this example. 0.0005. Is it a number between 1 and 10? No, it's less than 1. Since it's less than 1, so I move the point from here until it becomes 5. Since it's a number less than 1, so I will use a negative power of 10. 1, 2, 3, 4 digits, so I multiply by a negative power of 10. And also you will have the other examples to apply on a draft. The LCM and the GCD of two numbers. Of course, LCM is the least common multiple between two numbers, and the GCD is the greatest common divisor of two numbers. To find the LCM and the GCD of any two numbers, we should decompose the two given numbers into prime factors using the prime factorization method. Let me give you an example. Suppose I want to find the LCM and the GCD between 24 and 60. So the two given numbers are 24 and 60. I will make the prime factorization. I draw a vertical line and I write 24. I start. Can we reduce or divide the 24 by 2? First, I always try to divide if the number can be divisible by 2. 24 by 2 is 12. 12 by 2 is 6. 6 by 2 is 3. Can we divide 3 by 2? No. What comes after 2? 3. So 3 can be divisible by 3. My answer is 1. So my prime factorization finishes when the answer of division is 1. So what are the factors of 24? I write the 24 equal 2 times 2 times 2, which is 2 cubed times 3. Let's find the prime factors of 60. These are the prime factors of 60. So I write 60 equals 2 squared times 3 times 5. Now, to choose the LCM, I look at these factors and these factors. In LCM, we choose the more common factors with the highest exponents and not common factors. So I say 2 is a common factor. Which 2 has the highest exponent? It's 2 cubed. So I take 2 cubed in LCM. 3 and 3, they both have an exponent 1, so I take any of them. Is 5 a common factor? No. In LCM, we take the not common factor. So the LCM is 2 cubed times 3 times 5, which is 120. And to choose the GCD, we take the least common factors with the lowest exponent only. So between 2 cubed and 2 squared, I take 2 squared. Between 3 and 3, I take 3. I do not take 5 in LCM. So my GCD is 12. Also, this exercise is very important to apply it on a draft. This was our last lecture in this lesson for this week. Please watch the video well, and whatever questions you have, please contact me on WhatsApp. Thank you.